Okay, so today we're going to be graphing parabolas. So let's crack out those notebooks and let's get cracking. So we're going to graph quadratic functions. So it's like say it again?
Don't worry about it.
All right, I'll try not to worry about it.
So what's the difference between this and graphing transformations?
So we're actually going to start with graphing by transformations today, because that's something we already know about, and then we're going to move on to graphing in a different manner, which is a little more complicated. Okay, so speaking of graphing by transformations, let's make our sketch. So we're going to sketch y equals 3 times x minus 2 squared plus 4. 3 times x minus 2 squared plus 4. All right, so how do we graph this thing? I have no clue. Really?
Wouldn't you like do the thing where
You first start by going up 4.
Okay, so this means plus 4 means to go up 4.
Yeah, then you go to the right 2.
That means to go right 2.
Yep.
And
Then you put a dot.
Okay.
Start through.
So let's start with that. So up 4, right 2, so we go right 2, up 4. 1, 2, 3, 4. Put a dot right there.
and the slope is
And the slope is 3.
I keep
Take the out on accident.
So that means we're going to go up 3 over 1,
Yes.
and up 3 over 1 over here. And what's the shape? It's a U shape, right? Because the quadratic thing right there, the squaring means quadratic, and quadratic means U-shaped.
I apologize for putting it off.
Okay, that's all right. I knew it was a mistake. All right, so there it is. We have our quadratic. We have our U shape. So this we already know. We've already done this before. So, just like back in the day when you were taking geometry, this point right here on the triangle is known as the vertex.
Yeah.
So the point of the triangle is known as the vertex, and the point of the parabola is also known as the vertex. Making connections back to stuff you already know. Everyone's cool? Good. And in fact, what are the coordinates of the vertex right there?
You just said the coordinates of the vertex.
The coordinates of the
Oh, the
vertex.
coordinates. I was like, what's the coordinates?
So what are the coordinates of the vertex there?
2, 4.
2, 4.
Yeah.
So we're at 2, 4. So if we were to look at this equation right here, could we just get the coordinates of the vertex right out of it?
Yeah.
Yeah. How would we do that?
The 4 and the 2.
The 4 goes right there.
Yeah.
And the 2, actually what kind of 2 is this?
That's a negative.
This is a negative 2. What's this 2?
That's positive.
Positive. So in order to get this, all we need to do is
Multiply by 1.
multiply by negative 1 or change the sign or however it is that you describe that. So in order to get the vertex, the y coordinate is this number out here, and the x coordinate is the opposite of that number. Everyone's cool?
Yep.
Good. Okay. So because we can get the vertex right out of this equation right here, this equation is cleverly known as vertex form.
Oh. That's close.
This is the vertex form of a parabola or a quadratic. So we already know how to graph when we're in vertex form. We're going to learn how to graph today when we are not in vertex form. Okay. Awesome. Incidentally, actually, let's just make sure we can do this. So I want you to find the vertex for y equals 4 times x plus 8 squared minus 1. Please take a moment, and this is a really easy problem, to find the vertex for that parabola right there. Good, somebody's already dropped the mic, very nice. Nick dropped the mic. Everyone's cool already? I hope. Good. What do we got for the vertex?
-8, -1.
-8, -1. Boom.
Let's see.
How many of y'all got that correct? Boom. Okay, great. Questions? Are you good, Joe?
100% sure. Because I just took the positive, positive 8, assumed that it is positive, so I just put that down.
Okay.
So let's do the opposite.
So remember from this example here, we did the opposite of whatever was inside the parentheses and kept this one as is. It's good? Okay, great. All right, that's old stuff. Let's go on to new stuff. So do you think our other math friends will be watching the video someday?
No.
Is this going to be on Wiki Math?
Yep, I'll put it up on YouTube. I know.
I think subscribe to you actually.
There you go. Good times. All right, so let's make a sketch of y equals x squared minus 4x plus 4. And you'll notice, of course, that this is not in the same format that we were just looking at. There's no parentheses, and that's the key element, the key difference here. So we need to find a way, or we need to have a way to find the vertex, because that was what was the most important point of our parabola. So, as a matter of fact, we have a formula to help us find the vertex. So here it is, formula for x coordinate of the vertex. But before I give you that formula, I'm going to give you 3 names. But I'm going to talk to Nick first. Nick, why is your name Nick?
Because my parents were somewhat cruel.
Oh, okay. Good.
Wow.
Good.
I don't know.
Yeah.
Always said you-
I mean, ultimately the answer is, because my parents wanted to call me Nick. Nicholas,
Well,
probably.
I guess if you like thought about Nicholas, then yeah, I think because that's a lot of stuff.
It is. It is. So,
So
but
I-
names for the most part just come about because somebody wanted to call that thing by that name. That's what it is, right? Okay. So, we're actually going to name some things up here. We're going to name the number in front of x squared. We're going to name it a.
Hey.
The number in front of x, we're going to name it b. And the number out there all by itself with no variable, we're going to name it c. So these are just names. There's no other reason why these are a and b and c other than because Nick's parents wanted to call them a, b, and c. That's it. That's the only reason they're a, b, and c. We have to have a name so we can call them. You know, so instead of Nick running around the house and his parents continually going, hey, you, it would be just nicer if they had a name.
Number one.
Exactly. Right. So, we name each of these things so we can now talk about them and put them into formulas. So, the formula for the x-coordinate of the vertex is negative b over 2 times a. Negative b over 2a. So, we have the second number, or the number in front of x, with a negative in front of it, change the sign, divided by 2 times the first number. So there's our formula. You need to memorize this little bit of formula right here. I know. 2 letters and a number. I think we got it nailed down. Okay, so let's use this formula to find the x-coordinate of the vertex. So we got x equals negative b over 2a. So what's the value of b right now?
Negative 4.
And what is a negative negative 4?
Positive.
Positive 4. And then over 2 times a is? 2 times 1 is? 2. So 4 divided by 2 is 2. So we now know that the x-coordinate of the vertex is 2. Everyone's cool so far? Great. How are we going to go about finding the y-coordinate of the vertex? Is there anything up here on the board that says y is this thing?
You wouldn't plug 2 in for the x's.
Yeah, just plug 2 in for the x's, and that'll tell you what the y is.
Hey.
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 Good. So we're going to do that. So y equals 1 times 2 squared minus 4 times 2 plus 4. So 2 squared, of course, is 4. 4 times 2 she is.
-8.
So negative 4 times 2 is negative 8. So 4 minus 8 is negative 4. Plus 4 makes 0. So the y-coordinate of the vertex is 0. So our vertex is 2, 0. Everyone's cool? Great. So we're almost there. So what is the other piece of information we need, or that we used from the other type of graphing, to get us the rest of the parabola? Once we knew where we were going to start, what did we do after that?
We needed the slope.
We needed the slope. So, what do you think the slope is in this thing?
1x.
Yeah.
Not 1x, but just
1.
1. Just like in the other thing, the other format, the vertex format, the slope is in front of the squared term. This one's also in front of the squared term, so the slope is going to be 1. So our sketch, vertex is 2, 0. And from there we're going to go, no, put your phone away please, over 1, up 1, over 1, up 1, and then we're just going to connect the dots.
Then what's all the other stuff for? Is that just like, just to find the B and the C? Like, does that mean anything?
What do you mean the other stuff? So there's an A and a B and a C.
Yeah.
We use the A and the B.
So all the B and, wait, what's
Right, so we use the B and we use the A.
okay, yeah.
Okay, and what do you suppose the C is all about?
The Y intercept.
Right. The number out there all by itself is the y-intercept, just like it is in y equals mx plus b. So, 1, 2, 3, 4, there it is. Isn't that cool?
Fancy.
Good. Questions? Anyone? First one of these all by your lonesome so far? Okay. All right. Okay. Let us pray.
Pray to the monks.
Okay, we got that. That's good.
Make that a sign in the class. Pray to the monks.
What was that?
You see it? Pray to the monks.
Yeah.
Everybody walk in the room. We want.
So y equals x squared plus 2x plus 5. So please take a moment, all by your lonesomes, to make a sketch of this, and then we'll talk more. We'll add on another layer here. So use the same procedure we just did to find the vertex, and then use the vertex and the slope to make the sketch. Actually, to save everyone a little bit of time, including all the guys that are going to be watching this, I hope they're going to be watching it anyway, let's actually just go through it together so they're not just listening to dead air. Okay, so how do we find the x-coordinate?
Do the A, B, C thing.
Good ABC thing. So A is 1, B is,
2,
C is.
5.
Great. So we got x equals negative b over 2a,
Which is
negative 2 over 2, which makes
Negative 1.
negative 1. So we know the x-coordinate is negative 1.
Mhm.
So getting the y-coordinate, just plug in negative 1 into here. So negative 1 squared is 1, right? Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2. So 1 minus 2 is negative 1. Plus 5 is
4.
4. So the y value is 4. So our vertex is negative 1, 4. We're all good with that?
Yep.
Okay, great. And the slope is,
Why?
try again.
Oh,
Slope is
Negative. Oh, yeah.
1. Slope is 1, right? It's the number in front of the squared term.
Questions.
What's the y-intercept, by the way?
5.
5.
8.
Okay, so we got negative 1, 4. So there it is, negative 1, 4. And then from there, we're going to go
Get that, Miguel?
Up 1 over 1.
up 1 over 1, up 1 over 1, up 1 over 1, and connect the dots. Are we good so far? Great. So we know that parabolas are symmetric. In other words, they're the same on both sides. And so there's actually a line that we can draw right down the middle. And that line actually goes right through the vertex. And what is the name of this line right here? What is the equation for this line?
Y.
What was the
Oh, wait,
question?
no. X equals negative 1.
X equals negative 1, right? It hits at negative 1, it hits the x-axis, so x equals negative 1 is our equation of axis of symmetry. The axis of symmetry, an axis goes through the middle of something, and axis of symmetry, this cuts right down the middle, left side, left and right. You should be writing this down, Noah.
I have it somewhat done.
You do? You have axis of symmetry written down on your paper?
Not that good.
That's what I thought. Punk. Okay, so equation of axis of symmetry. And in this case, it's x equals negative 1. What's the vertex?
Negative 1, 4.
Negative 1, 4. So what's the easy way just to get to the axis of symmetry?
The x-coordinate of the vertex is the axis of symmetry.
The x-coordinate of the vertex is the axis of symmetry. The x-coordinate of the vertex is the axis of symmetry. Nick is on fire today.
My face shows it, right?
Yeah, it does. Questions so far? Okay, great.
So you look up on your own speeches. Oh, God.
You're gonna stab yourself in the neck? Is that what you said?
In the leg.
Oh.
I stabbed myself in the leg and I got caught in this thing and I was like, I'm sad.
So I've been watching a fair amount of Game of Thrones and Vikings lately.
No.
Yeah.
There is a lot of stabbing in the neck.
There is. It's effective.
It does work fairly well. That's what I see.
I've seen the game before. The game before. It's like that. It's not good as it's stabbing each other.
Okay, so y equals negative 3x squared plus 6x plus 1.
Let's do it.
What's the difference between this one and the other ones we've done?
It has a number in front of the x.
It has a number in front of the x, good, and that number is also,
Negative.
which means what's going to happen to the parabola?
It's gonna flop.
It's going to flop. It's going to flip upside down.
What's the difference between
Flip and flop. Not really sure. All right, so please take a moment to. Oh no, we're actually going to do this together. That's right. So there's no dead air. So we'll talk to little Garrett. Little Garrett, how do we start?
The negative b over 2a.
Good. X equals negative b over 2a. And in this case, we're going to have.
Negative 6
Mhm.
over 2 times negative 3.
Which is also
Negative 6.
Yeah,
negative 6. And negative 6 divided by negative 6 is
-1.
1. So we know the x-coordinate of the vertex is
And
1.
the axis of symmetry.
It is also the axis of symmetry. Okay, good. Little Garrett. How do we go about finding the y part of the vertex?
Plug in the x.
Plug in the x into these.
Oh yeah.
So we're going to have a 1 here, so that's obviously going to be 1.
Yeah.
Times negative 3, of course, is
Negative 3.
Negative 3 and then
plus.
what isn't it?
It's going to be 9.
Oh yeah, I was gonna say isn't it squared?
Oh, no, no, no. So the 1 goes here. What's being squared?
Oh,
Only the x.
Okay, yes.
Right? If there was parentheses around, then we square the negative 3 also, right? So we get negative 3 here,
Yeah.
plus
6,
makes
6.
negative 3 plus 6 makes
Oh, 3.
3, plus 1, she is 4. So we know the x is 1 and the y is 4. So we have 1, 4 for the vertex. Everyone agrees?
Yeah.
Okay, great. So vertex is 1, 4. 2, 3, 4. There we are, 1, 4. And then where are we going to go from there? We need our slope. What is the slope? It is negative 3. So we're going to go over one end, down 3. Over 1, down 3. Over 1, down 3. Everyone's good so far? Good. So Aletha has already nailed this down for us. We know if A is positive, the parabola will open up. If A is negative, the parabola will open down. So
How
let's
would
put that right here.
open sideways?
If we have y squared.
Please no. Please no.
So if
We should go.
A
There are at least
is positive, parabola opens up, and so I'm just going to draw a little sketch of an opening up parabola. If I had more board space, I would have left this here and then made a connection to a problem we're doing a little bit later. So if we have a parabola that looks like this, you don't need to draw this. So does this parabola right here, does this have a minimum value or a maximum value?
Minimum.
It has a minimum. It is the lowest point, right? We have a lowest point, it is a minimum. So when we open up, we have a minimum. So if A is positive, the parabola opens up, and there is a minimum. We'll talk more about that in a few minutes.
So I take it as if it's negative, it has a maximum.
Correct. If A is negative, parabola opens up, and there is a max.
What do you mean opens like down?
No, opens down. You are correct. That's what I meant to say. So the parabola opens down, and there is a maximum. Everyone's cool? All right, awesome. We're blistering right through this. Okay, great. So let's talk quickly about domain and range, which we actually had a problem over there, number 22 from the test from a little while ago. Okay. So, find domain and range. You good? So let's say that our graph does this. So please take a moment to sketch that graph as best as you can. And we'll talk about the domain and range of that graph in just a minute. Really? Really, really? Oh, English acting, please.
He's living.
We're recording.
Welcome to the recording studio.
Mm-hmm. Doing a
Oh,
lesson.
is he really
Yeah,
taping
when we
this?
start.
I am really doing a video of this.
Oh, is that what that is?
Yeah.
Oh, okay.
Did you not know that?
Why would we
I
make like
it
stupid
didn't.
comments and
But
stuff?
Huh. Weird. All right, so the domain is all about the x's. So, what's the domain here?
Isn't it
Four.
x is, no, it's like 1 is less than or equal to x is less than or equal to 4.
Good. So, we find the leftmost, or the smallest x, we find the biggest x, and we list those, and then we put the x in between them. Did you find your paper? Yep, good, awesome. Everyone's cool on that? We remember this? Good. And the range, same concept, only we're doing this with y's.
So
-2
-2
is less than or
and
equal to y is less than or equal to.
it looks like 2.
I'm hoping it's 3. I meant it to be 3.
I was gonna say it looks more like 2.
Yeah.
So 2 would be here. 3 would be here. This is the highest point here.
Oh, yeah, never mind.
Right, yeah, that's not the highest point, right?
Yeah, never
Okay,
mind.
good, yep. Questions so far? Okay, great. Now let's take a look at a parabola. Still finding domain and range.
That's easier with parabolas.
So let's say that the vertex is there at 2, 1.
Okay.
So what I want to know is, what's the domain?
It is.
Infinite.
No, it's
Because it goes that way forever.
Right.
yeah, but it's the.
So,
the
just like with the domain over here,
point.
we're looking for the smallest x value that is covered by the graph. So Garrett says 2 is the smallest x value. Is he right? So here's 2 right here, smallest x value.
No, because it's going this way.
Right? Do we have 1,
Oh, I get
0, right? We keep going to the left. How far do we keep going to the left?
infinite.
Infinitely to the left. How far to the right do we go?
It's all
Infinitely
real
to the right.
numbers.
It's all real numbers.
Okay.
Every number is covered here, right? We're starting at negative infinity, going to positive infinity. It's all of the numbers. So the domain is all real numbers, big hairy R.
This is
I
just
may find just
extra.
like really
Say again?
morbidly obese.
Morbidly obese R. All right. Range has some similarities, but not quite. So let's go back to the concept of max and min. Does this graph have a max or a min?
It has a
Clearly it has a min, right? Smallest value, a min, the lowest.
1.
Okay, so 1 is the smallest value, right? That's what we did here. Go to the smallest, and then we go to the biggest.
So would it be 1 is less than or equal to y is less than equal to infinity?
Okay, so let's write that, and then we'll discuss how to change that. So 1 is less or equal to y is less or equal to infinity. Do we all agree?
Yeah.
And it is positive infinity. That's true, positive infinity. However, the only thing that we put in these inequalities is actual numbers, real actual numbers.
So would you
Infinity is,
Would you just do the hairy R?
stand by,
It's not.
infinity is or is not a real actual number.
It's not.
It is not, it is a concept. So, would we accomplish the same thing by just saying that we're interested in all of the y's that are bigger than 1, or equal to?
Yeah.
Would that accomplish the same thing? Yeah. And usually we just write it to the variables first. So we would write y is greater than or equal to 1. So I'm just going to erase this bit right here. And there it is, we have it. Everyone's cool with the domain and range? Great. Here's one for you to do on your own.
Finish. Come on up.
Your concept. Material being the concept.
We could have actually been doing things.
Mr. One was very
I was so
She had to
mad.
go sass. And
She was just saying, just stuff about it. I'll give you the kids in charge.
yeah.
Looks like you can't.
Yeah, because I like to see her.
Okay, boys and girls.
Or any other.
3-2 is the vertex, and we're opening downward, so please take a moment to find the domain and range for this parabola. Come on, we gotta get cracking here. We should be done, right? Little Gary, done?
Yeah.
Good. What you got for the domain, yo?
Well, I mean, not in per se, because I have no clue what I'm supposed to do. I'm questioning if I should put the all real numbers, but I don't feel like that's right.
Okay. So the domain essentially asks, what is the smallest x value? What is the largest x value? So as we look at this arrow right here, is it pointing, how's this arrow pointing?
Down.
And? Down and left. True story? Is it going to stop going left?
No.
Down and right, not going to stop going right either. Right, so this goes all the way to the left and all the way to the right and everything in between. So it goes from negative infinity to positive infinity and everything in between. That covers all the numbers.
I just didn't know if it was the same for if it was flipped.
Yeah.
That's all.
Can we make a general conclusion?
Parabolas have
All real
Yeah, the all real
numbers.
numbers.
The domain is always going to be all real numbers.
The domain is always going to be all real numbers for parabolas. Does that make sense? Unless I said, oh, let's stop it right here and let's stop it over here. If I don't tell you to stop, it just keeps going. All right, how about the range?
Y is less than or equal to 2.
Y is less or equal to 2, right? Here's the maximum and we go below that. So Y is less or equal to 2. Everyone's feeling cool? Okay, great. So, speaking of maxes and mins, let's put this into some context. So it is a true story that if we throw an object up in the air,
Then come back down.
it will come back down. And in fact, when we throw an object in the air, it will reach a maximum height. It will reach terminal velocity if it's up high enough. So, anything that has a maximum and then comes back down,
Also has a minimum.
not necessarily, right? So this has a maximum but not a minimum.
Sure.
It does keep going down.
Floor.
However, if it impacts the floor, that'll be the minimum.
Yeah.
So, because throwing something up in the air and bringing it back down, or having it come back down, has a maximum,
And minimum.
we can model it with a quadratic, because quadratics have maximum, or maxima. So,
Is that really the plural of maximum?
maxima, yep.
That's fun.
So it's not like maximize.
So, projectile motion model. So anytime we're throwing something up in the air, we can model it with a quadratic. And in fact, we can model it with this specific quadratic. The height of some object thrown in the air this is the gravity bit, and gravity is always the same, so you're always going to have negative 16 t squared in these problems. Plus What controls how high a ball will go up in the air?
The force of the throw.
Okay, the force of the throw, and how are we going to measure that? Say again?
Velocity.
The velocity of the throw. In fact, that's exactly what controls it. So, all we need to know is how fast was the ball going when it left my hand, and I'll be able to figure out very closely how high it's going to go. So, we call that velocity V0. Velocity at 0 time. So if we know how fast it's leaving my hand, then we can figure out how high it's going to go. And because this is a quadratic, we got a t squared thing, we got a t thing, and then we're also going to have something without a variable. What's the other piece of information we need to know in order to figure out how high that ball is going to go? Where it started. So if you're a very tall person and you throw the ball up at 50 feet per second, or you're a very short person and you throw the ball up at 50 feet per second, which ball is going to go a little higher? Right? The higher you release, the higher it goes. Okay, so we need to know the initial height. So this is initial velocity, and this is initial height. So this is the formula that we always have for projectile motion. Everyone's okay?
Yeah.
Great. So we're going to have time to do about one problem here. So, little Garrett,
Yes.
two R's and two T's? Yeah.
Correct.
Garrett throws ball straight up.
Ball.
Straight up at 64 feet per second from 7 feet.
Wish I was 6 feet.
Why did you have to do this, Barry?
I don't know.
Well, when you release the ball, it'll be about a foot above your head, right?
I guess.
Yeah, so about 7 feet. I mean, unless you throw an underhand.
True.
Okay, so first I want you to write the model for this. Part B. When max height C. What max height? Everyone's good? Okay. So, I'm just going to draw just a little small diagram for this, and that will help us to figure out a whole lot of stuff. Okay, so here it is. There's the flight of the ball. Looks an awful lot like a parabola, and this point up here is the
Vertex.
It is the vertex, which is also the max. So if you want to find the max or the min, that really just means find the vertex.
Which is also that other thing. Yeah.
So to find max, min, find the vertex.
No.
But if you were finding the min, you would change the negative 16 to positive.
Correct. And because well, gravity is always pulling down, that's why we have a negative 16t squared, because gravity is pulling down, negative down. Okay, so we're going to write the model. Oh boy. That's very unfortunate. Plenty of time. H equals negative 16t squared plus 64t, right, the initial velocity, plus the initial height. There's the model. Everyone's okay?
Yeah.
The T X is 64.
Okay, great. So there's part A. Part B, find when. In other words, so we want to find t. In other words, the first coordinate of the vertex. So t equals negative 64 over negative 32 equals 2 seconds. I just used negative b over 2a. Obviously, I'm rushing now because we're running out of time.
Yeah.
Right, negative b over 2a. 2 seconds is when it reaches its maximum height.
Pretty quick.
Part C. What is the maximum height? Well, plug 2 into here and we'll find out. 2 squared is 4, times negative 16 is negative 64. 2 times 64 is 128 plus 7, or 71 feet.
That's it.
So 71 feet is not terribly high, because 64 feet per second is not terribly fast. Everyone's feeling cool? Okay, awesome. I have an assignment for you. Okay, boys and girls who missed class, enjoy your assignment.